Hello and welcome back to compiler programming. Today I want to work on the oldest remaining issue that I have, which is support building compiler on Linux. In fact, the name is not exactly correct. This is more of a support JIT execution on Linux. And if I implement a couple of these remaining things, we don't actually need DL open for the basic JIT execution. That's something else that we need to take care of. But if I just do the right thing with memory and I support a Linux call convention, then everything should be fine. I have to confess that I wanted to do this video a couple of weeks ago, but I realized that there was a lot of stuff that needed to be cleaned up before that, so that is what I was doing in the background. I was kind of setting up everything to be able to have multiple calling conventions for functions, and in fact Linux support is not the only interesting thing I'm planning to do with that, so stay tuned. Anyway, let's dive right in, and this is our runtime file for the Windows version. It has quite a lot of stuff, and I don't think we need most of it for the Linux one, but we can start just by copying the runtime into something like linux runtime.h. Good, then we can open this in here and start cleaning up. So I don't think we need a special platform header, at least for now. So let's get rid of that. We will need something like that, definitely, but it probably will look slightly different. I don't think Linux supports structured exceptions. We have signal handlers, of course, but that also will be something else. We obviously don't have runtime function. We don't have this stuff. I don't think we need this. The same for these two functions. They all have to do with debugging and runtime exceptions. While I do want to have debugging eventually, that is not what this is all about today. So all of this goes away. Ensure last page is writable. That is something that we actually do need. Essentially in JIT, I can show a bit later what happens there. Protect from, yes, we do need this. We do need this. That's fine. Let's quickly review this function as well. So program buffers, that is fine. We need all of that. Code protected size, yeah. So that's actually the comment that explains why we need to switch between writable and executable mode. So you can pause the video and read it if you're interested. Okay. So I think we can get rid of this stuff as well. This is again specific for Windows, and for now I don't know what we need specific for Linux, so we're just gonna assume we don't need anything. Okay, so yeah, this is the part that is about DL open, and as I said, I think I will just not do that. So I will say panic to do support DL open on Linux. That seems fine. Function table, I don't think we have it because that's for runtime exceptions. Functions, that makes sense. We get the builder, we get the layout, and we encode it. Right, and then again we have runtime function and exception data. So this stuff definitely goes away. Patching labels makes sense. Section protection makes sense. Section protection, right. So I did a quick read of flash instruction cache, and it looks like I don't actually need it on Linux, or if I do, I'll need to do some inline assembly. So for now, I'm just gonna say that I don't. And then if we do need it, then we probably will figure it out later. So I guess that also is going here. Okay, relocations, that is something that is not dependent on on the platform, so I think we should be even able to extract this logic somewhere. And sorry, the same goes for these things. So yeah, there is definitely some cleanup to be done later on, but I think that is about what we need to do. Now, we probably want to replace Win32 with Linux in this file. So let's do that. Okay. And these functions, right? So Linux obviously doesn't have the word. I think they are just integers, but we can try to go to and protect. Yes, this is what I want. All right, include sysmn. That is fine. And by the way, we probably want to change this stuff as well. So Linux runtime H. Great. And protect is basically equivalent to the virtual protect in Windows. So this is what we need to call protect. Okay. We can even do void star address is this. So address, page size, and protection, which is equivalent to these kind of things. Yeah, and here are the constants. I don't think I need these two for now, so I'll just stick with prot non, prot read, and prot exec. They actually should go, yeah, they should go in here. And so on Windows, you can't really toggle individual permissions, but what about Linux? Blah, 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 traced access memory, protest combination of the following access flags, prot non and bitwise or, okay. So this is actually pretty cool because that means that there is much better correspondence, and Windows I have to do this very weird nested if stuff. So I think what we can do here is literally just do something like that. And then we have the right one. Actually, no, we don't return right away. We say int prot is prot none. I don't like to do shorthands, but when shorthand matches the expected terminology, then I think it is okay. Although no, let's be explicit. Oh, they call protect flags to not virtual protect to let's call it protect flags. Yes, this is what we will call this. Okay. Good, so protect flags, none. Here we add protection read, that is good. Here we add protection write, and I think finally we have these prot exec. We can get rid of this stuff. We don't need any of these, and we return protect flags. Right. So that is probably what we want, and in here, in ensure writable, we just do prot read and prot write. Okay, and so the thing returns an int. What does it actually mean? return value on success, blah blah blah, return 0, and okay. So for now, I think what I will do is I will just say if 0 is not mprotect, then I will just panic to do, or actually this is what we will do. I'm just gonna crash if we can't change protection, because I don't think there should be a reason why we can't change protection. Like, we created that memory ourselves, so that is indeed a panic. Like, I don't expect that this is something that should happen, but it's never bad to be cautious in these kind of things. Okay, the same sort of deal, but here we do get the flags from the function which we just edited, so this function. Okay, protect flags. All right, so this goes into here. This is size to protect, and this is like this. Maybe it can be cleaned up a bit, but it is fine. Okay. So what else do I need to change? I don't know really. So let's get into the Linux part. So start with Ubuntu and do build.sh. Okay, so it looks like it actually worked for the first time. I do need to clean up these warnings, but I think, yeah, they are from sort of different place, so it doesn't really matter, I think. Okay, so let's try to run this, I guess. Build source spec, no, what? Oh, okay, yeah, that makes sense. So I actually had a suffix, so I don't try to run those tests on this CI. So I just build them, but I don't run them because we didn't have the runtime. Okay, that is fine. Guess let's try to make it like so. I think now we can do test sh. That is not very encouraging. Okay, so it looks like even in tests there's something wrong. Okay, I also disabled this stuff. Right, it was when I did the function spec removal. Okay. Let's get this thing. But obviously we do get segmentation faults, so that's something to look into. And I think I do want to actually build and run separately because it just looks better for now. But it's good that I can do test sh on the CI. So build source spec. Okay, segmentation faults. That's not good. Build source spec run bt. So I'm trying to call a null function. That is not great. Descriptor function instance. Right. Okay. Yeah, that makes sense. So as I said, I did some preparation work for the calling convention, and the way that calling convention works is that we have these sort of static objects, and they have setup for which registers are considered volatile and which are not. And I actually did the preparation for this for system V5. I don't know how to pronounce that. But basically, this is the calling convention on Linux and on Mac for JIT-execution. Maybe for some other platforms as well, and this is not full because it's missing the actual functions that we need. Okay, well, I guess we need to make that happen. So we say Linux, right? And let's go into function.c and make a copy of them. So okay, it kind of is bad that they are spread across the file. So this is return storage and layout. Yeah, so I think I will just put it now here so they're close to each other. And yeah, these are 3 functions that I'm interested in. For now, we are just gonna copy all of that and replace again Linux here, Linux here, and Linux here. Now this thing is not a part of runtime because eventually I want to support cross compilation, so I should be able to compile to Linux on Windows, while this thing actually can only run on Linux because it requires on these like mprotect and so on syscalls, right? So anyway, I do need to also set these things up, right? And again, this is Linux. Okay. And let's do a quick review of what these things actually do. So I don't think this is something that happens in system 5, whatever the calling convention is. So let's disable these for now. I don't know if we need this, but if I just can get like basic functions working, so 1, 2 register based arguments, that is perfectly fine, and there's definitely going to be a long tail of fixes for various parts of calling convention, especially because there is this thing with system 5. I do need to learn how to read this. So system V. So it's read system 5. Okay, so system 5 calling convention. It's quite complicated. It's actually way more complicated than the Windows one, at least from my perspective. But maybe I'm wrong. Right. I think we can keep this part. We'll see if that causes any issues. Essentially, what that does is it deals with the layout of the stack memory. I can actually open the system 5 ABI. Right. So as you can see, this is not a small document. It describes like what kind of types there are and so on and so forth, bit fields, and function call system is sort of what we're interested in. And basically this code here, what it does is, here. it is implementation of more or less this thing. So this is the stack frame for the previous function. So yeah, these are arguments, and this is the stack frame for the current one, and the stack pointer, as you can see, is at 0. This is when we do stack reservation, and then to access the variables, either argument variables or regular variables on the stack, we need to do offset, and this code here is exactly what calculates all of these offsets for each of the variables. Anyhow, let's get to the next one. This is probably okay. I don't think that this happens on system 5, so we will keep it like this, I think. I'm not sure exactly. We can switch back to here and actually look at no, I don't want to protect, I want to close this. So what I wanted to check is where is parameter return. So this is parameter passing. First return register, second return register. So yeah, unlike Windows 1, we can actually have multiple returns, I guess. Okay, that's fine. Okay, well, for now this will do, and then I will figure out later, as I said, for the complex versions, what is going to happen. XMM0, XMM1 is passing and returning of arguments, and then XMM2 to 7 is passing. Okay, so essentially what that means is, I believe now I will need to do something like 4, 5, 6, and 7, and in here I think I can actually copy already from this one. Yeah, so these are the registers that are not that they used for arguments. So big difference between System 5 and Windows 1 is that System 5 actually allows to use way more registers for function calls than the Windows 1 does. So in Windows you can only use 4 general purpose registers for arguments, and in System 5, as you can see, I can use, I guess, 6. Yeah, used to pass 6th argument, and I don't see 7th one, so it's actually kind of interesting that I can use 8 floating point arguments, but I can only use 6 general purpose arguments. Passing function static chain pointer. Okay, yeah, there is definitely lots of stuff to dive into here, but again, I just want to make the simplest version work. Large return types. Right, so there is this whole procedure here around parameter passing and how to consider what goes where, and I'm not going to look into that because it's a very precise algorithm that needs to be implemented, and I myself don't exactly understand all of the things. There is also fun stuff, like if you probably need to zoom this in. there is a specification for C++ objects, so that's fun. Like I need to know if something is a non-trivial copy constructor in the called function, even if I don't care about C++. That's kind of but okay. Anyway, I think what I will do for now is I will just say, so yeah, this goes away, and if I get the large argument here, then I'm just gonna panic and say to do support large arguments, in on Linux. Does that build? Arg storage, potentially initialized. Right, there we can do it like this. So the thing compiles and does not complain. Or maybe I'll put it here. Okay, so that is arguments, and I think we are done. Yeah, I'm also not sure about the arguments that I passed on the stack. Do they start from the offset 0, or are they put into slots like they are on Windows? Anyhow, let's just get back here and we will try to rebuild and see what is going to happen. If we get any kind of functions working, that will already be very good, and then we can see if we can fix these other things or not. So build source spec. Right. Oh, this is fun, yeah. Because the expectation was, yeah, I need to rewrite this routine completely. So for now, that is, yeah, this is not at all how this convention works. I think we're just gonna keep it like this for now, but essentially there is a big difference again between System 5 and Windows call convention. On Windows, like if I have 4 arguments, let me say something like void foo, and I have int, float, int. So on Windows, sort of each slot here has a predefined register. Like if I have something going in this slot, this will be register C. This is, and then it doesn't matter if we have int or float argument, the position of the argument determines which sort of register you get. So this would be, I don't know, XMM1, just simply because it is the second argument. This is XMM2. This is on Windows. But on System 5, if I understand correctly, you count the index for each of the types. So if you have a float here, it will actually start with 0 and 0 here, and this is considered like a second int argument instead of being fourth int argument like here. So yeah, that's a big difference, and I will need to change how this works. So, but for now, I'm just gonna wing it and keep this as is the same as it is on Windows, and see where we are. Wait. All right, this should not be or these should be like so. Or large arguments on Windows, on Linux, sorry. Okay, let's just pretend that we do support them. This is gonna go terribly wrong, but you have to start somewhere. Okay, yeah, it makes sense that scope and tokenizer tests pass and type inverse because we don't actually do anything in those tests. So that's not the interesting part. And then when we try to JIT compile, we have this thing, okay, value 1785, 1785, right. So we have if defined Windows and that, and then here we say elif defined. Is it like this? I never remember, to be honest. I guess I can look for it. Oh, okay, so it is with the 2 underscores. Okay, so that would be Linux program JIT, and we do need to include this header in the file. So the same, just defined if Linux runtime H. Great. Let's try again. Okay, that is actually very good news. So as you can see, we have at least a couple of function workings, and this is more or less all I hoped for today, which means this code actually works. And yeah, we can go from there. Now the question is, I don't want to have to fix all of the functions at the same time right now, but I do want to have tests running on Linux in some shape or form. So how do I do that? I guess I can void function. Right. I think I can do some kind of macro. I can do something like this. If defined Linux so on Linux I will only run this test, and on Windows I will run all of them. That is quite a hack, but I think if it will work, that is fine. So let's try to run test sh now, and we'll see where that leads us. Apparently, it does not lead us anywhere. Right. So I do actually need to do it like this. I do need to clean up these warnings because they make it reading. Cool. I think that's what I wanted. Yeah, great. So as you can see, here we now have one function working just as we want. And that is pretty cool. So that basically means again that this code works fine, I think. At least it works in the first pass. And there's definitely stuff to do in here. There is lots to do in the sorry, in here with the way the arguments are assigned. But at least we can let's actually run the tests on Windows. At least I think we can commit this version and go from there. I might try to very quickly take a look at the sort of the algorithm for assigning arguments, but I will not dive too deep into that. Okay, so let's add this and we say commit -m initial support for Linux JIT fixes number. What's your number? It's number 14. Git push and ta-da! This is now closed. I can actually put apparently I cannot check mark on the closed issue, or yeah, I'm not logged in. Okay, fine. I will go later in a different browser and fix all that, but that is very, very cool. Right. Let's take a quick look on the calling convention and maybe I can figure out how to do the basic setup here, and we can read through the algorithm and see what is again necessary to be done. So there are different types of arguments, and for now I'm just gonna focus strictly on these and maybe SSE ones, so the rest doesn't matter. Memory probably doesn't matter as well. Blah blah blah. Classification, bool, char, short, okay. Okay, makes sense. Makes sense. Int 1 to 8. Okay, that is going to be fun. I don't support int 1 to 8 for now, so that is not a problem, but we'll see. Complex also is not supported at the moment. If the size of an object is larger than 8 bytes or it contains unaligned fields, it has class memory. Okay, that's gonna be fun. The C++ thing, fine. If the size of the aggregate exceeds single 8 bytes, each is classified separately. Each 8 bytes, okay. Yes, I think this algorithm will need to be like literally implemented as it is defined, except for this whole C++ non-trivial constructor, which means I will need some kind of annotations to work on that. Okay. If the class is memory, pass the argument on the stack. This is actually very interesting. So unlike Windows, it looks like there is no implicit references, but I'm interested in this. If class is integer, the next available register of the sequence, RDI, RSI, RDX, RCX, R8 and R9, so that seems actually fine. If the class is SSE up, or interesting, yeah, so it looks like I can split the values into parts of the register. Okay, bool is interesting. Call argument. Okay, so what this says is that like if the whole struct does not fit into the remaining registers, then I think the whole struct is passed on the stack. The argument is passed in memory, are pushed on the stack in reversed right to left order. I'll need to think about what it means, if it is actually the loop I have to do in reverse or not. I guess, yes, I'll need to flip it, but okay. And then we have varargs and stdargs, prototype code. Okay, that is not something I'm interested in for now. And here we have the full thing. Okay, let's quickly read returning of values. Specify return type. If the type has class memory, then caller provides space for the return value and it passes address of the storage in RDI as if it would. Okay, so this actually is the same deal as in Windows. So I can actually do this here and do it like that. Right, and this is the same, so we can re-enable this stuff, except for I'm moving to ArrayX from RDI. It's kind of good to know. That means maybe I can abstract this logic for large registers as well. That is good to know. Okay. Now this, I guess, is RDI. And this logic also makes sense. Okay. Maybe we can try to re-enable this, so false and see where we are. Okay, that is actually very good progress. We just have a bunch of things here. Maybe what I will do instead, actually. Yeah, let's walk through it that way. We will go one by one and just disable the tests. Okay, so recursive calls do not seem to work, so I will just say if defined pin32 to do support on Linux, and we will go one by one and just see which tests fail. Okay, that is even more progress. Obviously, there is so floats are broken, and it looks like some of the math stuff is broken because the registers are assigned incorrectly, but that's fine. We have some problem with operators, apparently. Yeah, okay, so that makes sense because this test actually checks for these two tests. They are dealing with passing and returning of the large arguments, and I know that they are done incorrectly right now. I'm only interested in integer ones. So let's try again. Okay, this is even better. This is super encouraging. So a lot of compile time execution actually works, and even some of the large types work for some reason. That is kind of interesting. Okay, but I will not complain if it works. That is good. Auto dereference pointers. Okay, and yeah. And as I imagine we have problems with large fields. Okay, that's fine. I will deal with the large fields separately. For now, if integers are working, that is already amazing. Okay, I think we made a bit more progress again. With modules, it is sort of the same problem, because what happens when I call import, it actually again calls a procedure in the compiler, and that procedure just creates a bunch of large objects that are returned in the stack, so it is very obvious why this does not work. And I would expect these two to also not work, but we can try. Doesn't hurt to try, just takes a few seconds to compile this and run. But yeah, all of this is not gonna work for now. Alright, and this is the problem with slashes. I think I can just turn the slashes to the Unix version, and it will work just fine. These tests are disabled anyway, so I don't care about those. Here I need to change the slashes. Right, and it is very unlikely that FizzBuzz will work, but we'll never know. Yeah, FizzBuzz will definitely not work actually, because it relies on printing, and printing is I will need either a syscall or library for that to work, and I have neither right now, so all of that will not work. Let's try again. Relocation, support deal open on Linux, yay! That is not happening, so more stuff to disable, but if we got here, that actually means that we are done for now. Amazing, so we have 9 failed tests, a bunch of disabled ones, and that is pretty cool, I'd say. Well, I think that is all for what I wanted to do for today. Now what awaits me ahead is sort of this meticulous going through the tests, looking at the generated assembly, comparing it with something I can get from the compiler explorer, right? So I'll just go to godbolt.org, I will open it here, I will copy paste code, I will see which registers need to happen, compare it with what I have, and so on and so forth. This is very boring and very methodical work that needs to be done, but the exciting part is now we can run stuff on Linux. And this is very cool. I think we actually generated executables on Linux as well, so I can do build do wine build hello world, and I think that will actually work. Well, apparently no, it won't, but that's a separate topic to discuss. Yeah, I know why it actually doesn't work, because now that I compiled on Linux, it expects the Linux calling convention for the calls that are actually happening on Windows, and this is something to fix, but not today. So I'm very happy with where we are. If you watched this far, then thank you very much. I hope you enjoyed the content, and hopefully see you next time.